Alright, so I am back with our third installment of doing section 3.4. This will be going through example number 3 about how we use Pythagorean theorem in order to create a quadratic in which we can then solve and answer some questions on. For this particular one, there's really only one part. They only ask you to find the lengths of the sides of the triangular lot, and they provide you some information. So once again, drawing a picture is very helpful to make sure you organize your information. Some of the basic things that we need to remember is that the two sides that touch the right angle in a right triangle are called legs. The side that is not touching the right angle, the side that's across from it, this is called the hypotenuse. And unless it's a very specific type of right triangle called a 45-45-90, one of these legs is going to be a short leg and one of them is going to be a long leg. Okay, one will, if a 45-45-90 triangle shows up, then both legs would be the same. And if you knew the length of one, you would just know the length of the other. In this particular case, they do refer to a longer leg being 20 meters longer than twice the length of a short leg. So they will be using short and long legs. One of the other things we need to remember is what is Pythagorean theorem. That is set up as being a squared plus b squared equals c squared. But this could also be written as one of the legs squared plus the other leg squared is equal to the hypotenuse squared. Okay, you need to know that the A and the B both represent lengths of the leg. C is always the length of the hypotenuse. So we wanted to put that in here. We're going to call this leg A, this leg over here B, and then the hypotenuse is always your C. Like that, this relationship in this equation will always be the same. C in Pythagorean theorem is always the hypotenuse. So now that we have some of that geometry refresher out of the way, let's make sure we get the information from our problem. So the long leg B is being described as 20 meters longer than twice the short leg. So the short leg is A, we have twice that length, and then we have an additional 20 meters longer than whatever that is. So B could be written as 2A plus 20. So short leg's just going to be A, so we know its length. Then it says the length of the hypotenuse is approximately 10 meters longer than the length of the longer leg. So C is going to take whatever the length of the longer leg is, which is 2A plus 20. That's the length of the longer leg, and it's 10 meters longer than whatever that is. And so if you take the length of the long leg, which is 2A plus 20, we just established that, and add another 10 meters, that's going to be the length of C, which means you could write this as 2A plus 30. So now that we have a quantity for the short leg, we have a quantity for the long leg, and we have a quantity for the hypotenuse, we have three things, all using the same variable A, that we can now plug into Pythagorean theorem and be able to do some work for, to where we can start trying to figure out what the length of these these three sides of this property are. So with the A being squared, that's just going to be A squared. The length B, remember we said is the long leg, so that's going to be 2A plus 20, also being squared, because that's what Pythagorean theorem says to do with B, is equal to 2A plus 30 being squared, because that is what Pythagorean theorem says to do with your C, your hypotenuse information. So from here, it becomes some foiling for these two and some other algebraic work. So I'm just going to work through that, and then you can ask me questions on Monday or over the weekend once you read through this if you don't know where some of this information came from. So now that I've gotten everything combined to be on one side, I now have a standard form quadratic equation equaling 0, which I can now solve for a for. I'm going to check for factoring using a C method. So 1 times negative 500 is negative 500. Probably going to have lots of factors, but remember, we're trying to get to negative 40. So if you already sort of know that answer, that's fine. But negative 1 times 500 or 1 times negative 500, that'd be negative 2 and 250. Sorry. 5 plus 0 is only 5. 3 does not go into it. 4 does go into it. It ends in 0, so 5 does go into it. 6 and 7 do not do it. 8 does not go into it. 9 does not go into it. 10 does go into it. Negative 10 and 50, or 10 and negative 50. And so this is where I recognize that I've gotten to my negative 40 at with these two factors right here, positive 10, negative 50. So I do not need to continue doing factors once I have found a set that work. But if you need to complete that process, feel free to do so for whatever you're comfortable with. I just do my list of factors normally until I find the ones that make up B, or I reach the end. And if I reach the end and don't find a set, then I know that it cannot be factored, and I immediately then switch over to a quadratic formula. But I had to have a set of factors that work, so we're going to factor this. This becomes a squared. I'm going to rewrite the negative 40 using the positive 10a and the minus 50a minus 500. Here I can pull the a out and get a and then a plus 10. For these two terms over here, a plus 10 to make sure that I get the two binomials that match. That's how I know what number to try to pull out here. This should be negative 50, so negative 50 times a positive 10 is negative 500. I do still get that original answer. So now we can pull the a plus 10 out, get rid of that common factor, take what's left over, which is a minus 50. and we are at the point where we can use the zero product property to say that either a plus 10 has to equal 0 or a minus 50 has to equal 0. And when you solve, this becomes negative 10, this becomes 50. And once again, doing an immediate check here, we're talking about the lengths of a piece of property that's in a triangular shape. Can length ever be negative? The answer to that is no. So this is not a valid answer. Negative 10 is not within the domain for this particular problem. So that means the short leg, the only answer that we have left, the short leg has to be 50. And I believe the units they use in the problems are meters. And once we know what that is, we can come back to the way we define things. Remember, B is the long leg. So if we know A has to be 50, the short leg, that means for the long leg is going to be 2 times 50 plus 20, which I've written here. So you do that math to get 100 plus 20. So the long leg is going to be 120 meters. You repeat that process with the hypotenuse because we figured that earlier to be C is a 2a plus 30. So 2a plus 30, we know that A is 50. So that's going to become 100 plus 30. And so the hypotenuse is going to be 130 meters. And you will have now found all three sides of this particular triangular piece of property using the Pythagorean theorem and what you know about solving quadratic equations. That will be the last of the examples that we do in this particular section. I will not be doing the population data. So I'll be sending this out shortly, and I'll be looking forward to your feedback and our group meeting on Monday. So y'all enjoy your weekend.